Our next speaker is Yeungnam Ji, diploma engineer from the garment industry, garment production management at ESTV in Paris, France. Now working in Korea, Institute of Industrial Technology as a senior researcher. Her researching interest is apparel production management using computer systems and developing an automatic sewability prediction system for quality control. She'll be speaking on online quality control expert system for high quality garment manufacturing.
Good evening, ladies and gentlemen. Welcome to my presentation. At this conference, I present online quality control expert system for high quality garment manufacturing. This system has developed in KITECH according to the increasing of importance of the quality control in garment manufacturing industry in Korea. Recently, the Korean apparel industries tend to be more and more diversified in production items and more decreased in production quantities in each items. However, to get an accumulated expert knowledge for quality control in garment manufacturing, we often meet great difficulties in real situations. For example, when the concept and design head down, a fabric will be chosen and the experimented human expert will select a suitable subsidiary materials. Then he will control processing parameters which are based on their experimental but unscientific know-how. But these processes are not systematic nor scientific, so that we couldn't accumulate these data as valuable data. For these reasons, we have focused on the solving technological problems during the garment manufacturing processes, using knowledge base in this research. This system can guide us easily the optimum processing conditions to get a high and regular quality product. It has developed by online system using internet or LAN, and it simulates on human expert decision for the manufacturing process parameters. Generally, the expert system has developed a computer system that mimics the human's inevitable tolerances. The system is known in the various industries, including electronics, mechanics, chemicals, etc. It can solve the complex problem in a given domain. We in the apparel industry also may solve a lot of problems corresponding during the manufacturing processes. Through the application of the expert system, we can also get advantages, for example, increase in availability and reliability, quick responses replying consumers' needs, or reduction cost and risk, and unemotional and steady responses at all times, etc. The expert system in garment manufacturing, which we have developed in KITECH, has three functions with process design, diagnosis of problems, and prediction of garment qualities. To develop the online expert system in this research, we have defined 6 steps, as you can see in this screen. The first step is to define definition of domain and selection of the tools. The second is development of the prototype through formulating the application into the organized problem and collecting the preliminary knowledge and constructing the knowledge base and designing the inference engines. And the third step is to construct of expert system through redefining the prototype for effective implementation. And then test and evaluation of the expert system is done, and integration and implementation of the system. And last step is maintenance of the expert system is done for development in our system. This shows you a structure of our system. If we use an application program, we can use a very usable in real situation. So you can see in this screen. This development of the system, a lot of knowledge are acquired from the experiments, case studies, research articles, and technical reports. The knowledge-based system and inference engine were newly designed based on the optimum network model to use various inference strategies. All the systems were used Fibre mechanical properties data obtained from the Fibre assurance by simple testing measurement system called FAST system, and KITECH simple test tool. And also to get an additional effectiveness to predict tailorability, we have developed 3 types of expert system. First is online fusible interlining selection system, and second is sponging and decatizing process control system, and last is generated overall garment manufacturing guideline system. So I can explain more detailed system. The first system is expert system for fusible interlining selection system. The functions of the online fusible interlining selection system are the property analysis of Fibre and fusible interlining, and which is expressed in natural languages easily with fuzzy filtering for easy understanding of untrained experts. And the property prediction of composite material laminating. And then the control chart of composite materials. Composite material laminated first with explanation. And then optimum fusible interlining selector function. And last function, all these functions which result from the knowledge acquisition from Dr. Ben's paper or Dr. Nagano's paper in our experimental data. The first, the fabric mechanical properties data you can see in this screen. It expressed very easily to use in real situations. For example, the relaxation shrinkage, you can see the data, and the higher expenses, etc. And if interlining fabric mechanical properties too, you can see in the screen. And then we can, this system can predict prediction of fusible interlining, the suitability of the fusible interlining for the screen here. And then the control chart, if he is suitable for sewability or not, like this control chart. And then it predicts us with a very easy expression, like if the properties is good or not with fabrics or fusible interlining are suitable. And the second system is expert system for optimal sponging and decatizing processes. The optimal sponging and decatizing processes control system was designed to be applied to the apparel companies which are equipped with steam sponging machine or water sponging machine or semi-decatizing and or continuous decatizing facilities. The functions are the same. The first function are the same as the fusible interlining selection system. The first is which can show us easily the properties analysis of fabric and which expressed in natural language, and the prediction of fabric properties after sponging and decatizing processes. And then it shows us the optimal process line selection and processing parameters. For example, amount of steam or how many valves we have to open, or how is the roller speed, etc. These data are connected with Microsoft Excel sheet to support for reporting just for us. And then for apparel companies which keep some sponging machine, they can install this system and can use very easily and effectively. You can see the program here. So if we input the fast measurement data, the system shows us if it is necessary to sponging or decatizing processes. The last, since to using MS Excel program, the system shows us the data, and we can add some text or some comment with this data. And the last system is, which we have developed in KITECH, is expert system for online quality control document generation system. This system gives us an overall quality control guideline for high and regular quality product in garment manufacturing process. And it also can be connected with MS Excel sheet, and we can add our comment with the data. And it also shows us in natural languages the properties analysis of fabric mechanical mechanism. This is the important point of this is automatic quality control documentation of pattern or spreading or marking, cutting or sewing, finishing and inspection processes in apparel manufacturing processes. So you can see the first screen of the program, and if you select a number of the fabric measured by fast system, you can see the data like this. How is the relaxation, shrinkage of the fabrics or hydro expenses, etc. With a very this system shows us very easy expression by if the RS is low or proper or high. And the last, the quality control documentation shows us like this, the patterning processes, spreading processes, and marking processes, cutting and sewing processes. It predicts us the sewability. And with the Excel forms, we can use the command and we can add some our command. This screen you can see the whole system with integrated computer system, and we can use by net or internet for online to make an online quality control system. So we can control just to touch the computer. We can connect the file system with simple measurement data and etc. Through this research development, we have developed the online quality control expert system for high quality garment manufacturing as a component of apparel computer integrated manufacturing. And this system generates automatically the quality control guideline for guideline expressed in natural languages from the digital data measured with various instruments, including the file system or KITECH simple tester, etc. The important point of this system is an electronic data transfer to operator in actual manufacturing, actual garment manufacturing spots, and to using the web control technology directly control of the digital controlled parameters of manufacturing facilities such as sewing machine, fusing machine, etc. And composing of knowledge bases, inference engines, user interface, networking modules, control unit, etc. This online quality control expert system is composed with your knowledge bases. In conclusion, we expect through this system to substitute for untrained human experts of apparel companies. Thank you very much.
Thank you. Are there any questions, please?
Yeah, please. Well, first of all, I would like to thank you, Ms. Yeung, for sharing your thoughts. But the thing is that you have described the system, you have just designed the system for the garment industry. Okay? If you see in the world, the concentration of the garment industries here in the countries like Pakistan, India, Bangladesh, Brazil, I mean, these countries, they excel in this regard because they have low labor, they can compete on the cost. Now, you have just told us that in the beginning, that your system, by implementing your system, we can get down the risk of the danger, the cost of the risk for producing something, I mean, out of quality. Don't you think by implementing such integrated computer system, the cost of production would increase? That would eventually be increasing the production rate, and now the companies would lose the rate, the competition on the rate. Don't you think so? By implementing let me just put it simple. Don't you think that by implementing this system, the cost of production would increase? And therefore the countries where garments are actually being produced in the world, they would lose their edge in the market due to cost.
I'm sorry, I don't know if I understand very well, but if
Sir, could you please help her out to get the question?
Right. Well, the question obviously is, because of this new system that is introduced, in countries which manufacture fabric, which is Pakistan, for instance,
India, Pakistan,
countries that do it, and they're able to do it very inexpensively.
Yeah.
This system looks like it'd be an expensive way to market. How do you think it's going to affect them?
So yeah, but our opinion is if we in the apparel industry we can use, if we use the expert system like this, at the first time the cost is increased. But you know, if we don't need to, but so sometimes past with using this system, maybe we can get very regular quality product, so we don't need to lose the defective product for correct processing, etc. So some period after we can get the economical.
Okay.
Do you understand?
Yeah, I got your point. Thank you.
Any other questions, please?
You have not talked anywhere about what parameters went into the survey index. How do you, I mean, what properties and what performance measures did you use to define a survey index?
Did you repeat the question at the microphone?
I'm just trying to understand what particular performance measures she has used in defining the sewability. She has the obvious purpose of the system is to improve the sewability, right?
Sewability, yeah.
And I was trying to understand from a presentation what were the factors that she considered in defining sewability.
So yeah, just I show you the program. Just a moment, please. So did you ask me what parameters for the solubility, to predict solubility?
I mean, I have seen the properties. You have used EM1, EM2, E1, E2.
Yeah.
Those are the properties.
Yeah.
And, how do you relate those to swing performance? How do you define swing performance?
Yeah, maybe. We have researched many knowledge base from the technical report or research article already researched by other researchers, and I think in the research just what I refresh. To predict stability, we have
Let me put it this way: is number of defects per 1,000 garments a measure of sewability? Number of seconds in 1,000 garments, is it a measure of sewability?
The question is the number of tests per 1,000 garments. How many do you do?
test program.
How many?
Yeah. We at the first this system. Yeah, I understand. This system cannot applicable of all types of fabrics, all types of garments. To make this system, we used an wool shoot. How can I say? Bench shoot for wool. 100% of wool fabrics. We have chosen a lot of kind of wool fabrics for bench shoot, and we have tested for this system. So now now we calculate the system can apply just for wool fabric. So after we can develop on another types of fabrics.
Any other questions? Thank you very much.